Students, welcome back. Now coming to the next type of transformation in the 2D, that is a scaling. So let me write scaling. So far we have completed the rotation and the translation, and now coming to the scaling. So what is a scaling here? Actually this scaling it is used to alter or even to change the size of an object. Change the size of object. You can alter the object or you can change the size of the object. Whereas the rotation is the picture is going to be rotated in some angle. Okay, picture is that object is rotating in some angle. But whereas the scaling is, it is used to alter or change the size of an object. So the size is done using the scaling factors. There are two types of scaling factors. There are two scaling factors. So what are those two scaling factors? Sx, so which is in x direction, and sy, which is in y direction. So these are the two scaling factors. So based on the scaling factors, the changes can be done. The transformation scaling changes the object like, let me take the formula, x dash and y dash, the new coordinates. Sx is a scaling of factor in x direction, 0, 0, and scaling of done in y direction and the given coordinates. Okay, so the formula for this is p dash is equal to s dot p. So here, if scaling factor, if you take, let me write sf, if scaling factor is equal to 1, suppose if scaling factor is equal to 1, then the object size will not change. So remember that. So whenever the scaling factor here, if you just keep it 1, Sx is 1 and Sy is 1, then the object size will not be changed. Whatever the size that is given, the same size will be there. Okay. Suppose if scaling factor is greater than 1, greater than 1 means object size enlarge. Means it becomes big. When compared to the original one, the size of the object becomes enlarged. If scaling factor is less than 1, the object size will reduce. Less means reduce. Will reduce. So just remember these points. Okay. So let's take an example. Then you clearly understand how the scaling factor will affect the object to change the picture. So I already explained the transformation can be done only on the object that is already created. So changing of an object after creation, you call it as a transformation. Let me take the example for scaling. Make the size of the given object double. Okay, they are saying the scaling factor is 2. You have to make the size of an object double. Okay, that is a scaling factor they are giving as 2. So let me take this as a picture. 2, 4, 6, 8, 10. Let me write 2, 4, 6, 8, 10. Okay. So here one coordinates A has given as 2, 2, and next is 8, 2 and 8, 4 and 2, 4. So this is an object they are given. This A as 2, 2 and B as 8, 2, C as 8, 4 and D as 2, 4. So these are the coordinates. So now let me calculate P dash is equal to S into P. So P dash is, that is, you need to find out the new objects. So for each and every, so here I'm doing directly. So here S is the scaling factor, they are given it as 2. So Sx is 2, 0 and Sy is 2. And what are the coordinates? A, B, C, D. X is 2, Y is 2, and B coordinate X is 2, Y is 2, and C coordinate X is 8, Y is 2, and C coordinate X is 8, Y is 4, D 2, 4. So now calculate the matrix. So you'll get X coordinates are 4, 4, 16, 4, 16, 8, 4, 8. So did you observe here, all the coordinates becomes double. All the coordinates of the given original coordinates becomes double. Okay, so double means the object size is automatically it increased. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So 2, 4, 6, 8, 10, 12, 14, 16. So let me write the new points. So 4, 4. Next 16, 4. 16, 4. 16, 8. 16, 8. And then 4, 8. A 4, 4 and B 16, 4. C 16, 8. 4, 8. So did you observe here? This is a scaling. The size of the object is altered and changed. Means here the size becomes double. So that is a question they are given. You make the size of the given object double. They are given to make the size of an object double. So this is the size of the object they are given. I make it as a double by using this formula. Thank you.